In this video, we're going to talk about searching a little bit. Okay, so this next chapter we're doing, I think the Moodle had originally said we were going to cover trees. We're actually going to cover searching and sorting first, and then we'll cover trees after spring break. Okay, so we're going to start with the sequential search. So in this case, we're sorting on an array. So I've got here in Excel, just a basic array of numbers here. Okay, and notice that there's no order to the number. So when we're doing a sequential search, we have to start at the beginning, okay, and we have to keep going until we find it. Okay, so in this case, I have 10 elements. So in the best case scenario, I only have to search one time. Okay, if I'm searching for a 4, I'm going to find it right there. Okay, but if instead I'm searching for something like a 2, I'd have to do there. Oh, that's interesting. I have some random numbers in there, so they're jumping around and shouldn't be, but you get the idea. Okay, you'd have to go over that many times in order to find it. Okay, so there's no real trick to it. This chapter talks about some things that you'll hit more in algorithms, which is 3180. It's the next class typically that you'll take. Okay, so we're just going to hit it briefly here, but at least you'll have a preview. Okay, so this is what's called a brute force algorithm. Okay, that there's no trick to it. You start at the beginning, go till you find it. Okay, so nothing weird there at all. Okay, so let's take a look at what this looks like in the code. Okay, and this is in chapter 18 of the book. Okay, so and you're going to want to create a search directory for the homework and all of that. So let's start off here with the binary or the sequential search. But let me spell it correctly, which I hadn't before. Okay, so here's what the code's going to look like here. Okay, so I've got this function here, calling it sequential search. Note that it's a templated function, so I can send it any, I mean, we've seen this before, right? I can send it any kind of data, ints, strings, whatever we're searching for, okay? As long as it's something that can be compared, okay? So here's my function definition for sequential search. It's going to take the following, okay? It's going to take an array where this search can be applied to anything, but we're dealing with arrays in this case. Okay, so it's going to be an array of type, element type, whatever we're sending in. Okay, it's constant because a search shouldn't change anything. Okay, note that we have to track the length of our array ourselves. Okay, that it doesn't do that automatically for us in C++ like it does in Python. Okay, so then we're also going to send in another constant on what we're searching for. Okay, so we're sending in the item that we're searching for there. Okay, so we're going to set this up by initializing a variable for the, or creating a variable for the location. Okay, so this search is going to return. Note that it's an int function. It could be a bool function. Did you find it or not? But in this case, it's normally the way we do it is we're going to return the position where we found the item. Okay, or by convention a -1 if we didn't find it. Okay. So that's kind of what we're doing here. So we're setting up this location variable. We're also initializing a variable, a Boolean variable called found equal to false. Okay. And then we're also initializing, and I could have done this in one step if I would have wanted to. I could have done it this way. Would have been just the same. Initializing our location to 0. Okay. Meaning, thinking back on the Excel, we're going to start at that first position. We're going to keep going until we're done. Okay. So we have a while loop here. There are 2 conditions we're looking for. Okay, so while the location is less than the length, okay, so in our example, we're going to send in a length of 8, okay, and our initial position is 0. Okay, so we're going to go all the way up, 0 through 7. Okay, will be the things we're checking for here. Okay, so we're looking for that to be true and also not found. Because once you find the item, you don't need to search anymore, right? You've already found it. Okay, so that's what our loop's going to do. Okay, inside of that loop, we're going to check to see, did we find the item? So if the list at this location, list at the lock, okay, so the first time it'll be list 0. If list sub 0 is equal to the item, found is equal to true. Okay, if it's not, then you go on to the next time. You go into 1 to 2, all the way to get to the length. Okay, so that's what this little part of this while loop is going to do. Okay, so you're going to exit this while loop with 2 conditions. Either the location becomes equal to the length, okay, so when the location is equal to 8 in our example, it's down at the bottom of the screen there, then we're going to skip down. And if not, if found becomes true, we're going to skip down, okay? So then this little part at the bottom outside of the while is going to tell us if found is true, okay? So if found, return that location. That's the last one it was at, okay? Else return -1, okay? So then down here, I've just got a little program to test things out here. Okay, I'm creating an array. Note or remember, you can create them just in one line if you do it like this. Okay, I have some variables here. I'm setting up a couple of variables here. I should do better names here. This is my search term, and this is going to be the where it's found at. Okay, so yeah, that could be better. Okay, I could also set it here, which I didn't. The length, the int length equal to 8. It's not good to hard code these things, but you know, whatever. So we've got that as well. Okay. So then I'm asking the user to enter a number to search for, and it's probably not a bad idea here. Let me go ahead and put a quick for loop in here to print out just so we can see that things are working. Sometimes you forget what you've coded. Okay. For int equals 0 less than length plus. It should be able to see out a at I. Okay, and then I'm going to put in a comma space, keep it all in one line. Then when I'm done, I should be able to see out an end line. That'll clean it up a little bit from what the book had. Okay, well, the book didn't have a test program, it just had the function. So then I'm going to ask them to enter a number after they've seen it. Okay, I'm going to take the value, I'm going to search it, okay, to return that position. So F's going to go up. F will either be the position that we are in the list, okay, if it finds it, or if not, it will be a -1. So then I've got here, if it's not equal to -1, I say that S was found at location F. If it is a -1, then I say that it was not found, okay? So let's take a look at this one. So let me do my -o, sequential search.exe, sequential search.cpp. Okay. That would be having to spell it correctly, which I originally had not. Okay. So now when I do my sequential search.exe, it prints out my array. Okay. Let's say, let's do something we're looking for. So we've got 12 at the 0, 1, 2, 3 position. So if I do a 12, it's found at location 3, which is correct. Okay. Test it again. Let's check our beginning positions. Okay. Found at 0, which is correct. Okay. And let's look at the end condition, 43, found at location 7. Cool. Let's do something that's not there. Let's do a 99. 99 is not found. Okay. So that should be good, right? We should have that should work in any case. Okay. So sequential search is relatively straightforward, but one of the things we have to do with our algorithms is to figure out how efficient they are. Okay. So the book has a section on this, which you should read through, but we're not going to go into quite the amount of detail. Okay. So the main thing to think about it here is if we're trying to figure out what the average case is, okay, the average efficiency of this. So note that it could be we have to only try one time. It could be we try 2 times, could be all the way up to, if it's the last element or you don't find it, up to the length. Okay. So we can turn that into a formula. Okay. We're going to take how many tries there were over how many there are possible. Okay. Which is going to give us 1 plus 2 plus ... plus n possibilities. Okay. All equally likely divided by n. Okay. And you may have seen this in a math class somewhere, but maybe not. But 1 plus 2 plus ... plus n is equal to n times n plus 1 over 2. Okay, just a thing that we know. Okay, so when you put all that back together, you get that this is n plus 1 over 2 on average. Okay, so what does that mean? Okay, so that means basically that whatever your length is, on average, you have to go about halfway through, which makes sense, right? If you're going to randomly generate a list and you're going to search for it, you would expect to have to go halfway through on average, okay? Because your outliers are the really quick ones or the really slow ones, okay? So that's what the sequential search looks like, okay? But let's think a little bit, switch back to Excel. If we have a sorted list, okay, then we may be able to pick a better strategy. Okay, so here we have another list that's sorted. Okay. Now I could still start here and go to 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 here and so forth. Okay. But we're going to try this thing called a binary search that takes advantage of a sorted data structure. Okay, so it works for anything. We could do this one, for example, in our ordered linked list would be fine. Okay, you can do this. Anything that's ordered. Okay, so the idea here is if you were going into a big city and you wanted, and there were a phone book, which don't exist anymore, but it was a big book that had everybody's phone number in the entire city in it. Okay. Or let's do a different example. Let's say you have a dictionary. Okay. You got a big old dictionary. And if you're looking for a word like majestic, okay, the sequential search would have you start on page 1 and go through every page until you found it, right? But that's not what you would do. What you would probably do would be to go to the middle, okay? If you go to the middle and see where you're at, okay, you're left with 2 cases, okay? Either the item that you're looking for precedes the page that you're on, or it comes after. There's no other option, okay? So that's the idea of the binary search. We're going to go in the middle. Okay, so in the case here, we're going to have our first position right now is equal to 0. It's on top actually. Well, no, I put it here. So 0 is my first position. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is my second position. Okay, I'm going to calculate over here 9 plus 0 shows a 0 divided by 2. Okay, we're going to ignore the fractional point and say 4. Okay, so we're going to say 0, 1, 2, 3, 4. This becomes our midpoint. Okay, so let's say we're searching for, let's do our something at the beginning. So we're going to searching for the 7. Okay, so this is our first midpoint. So we're at this midpoint here. We're going to see, does a sub 4 equal to 7? It does not. Okay, a sub 4 is equal to 54. So there are 2 possibilities. Either 54 is greater than 7 or it's less than 7. If it's equal to 7, we're done. Okay, if it's less than 7, since numbers are getting bigger, if it's bigger than 7, numbers are getting bigger, so it's not going to be any number here, right? So we can exclude this. Okay, it can't be any of those. Okay, I can then reset my right or my end position, whichever you're doing, left or right or first and last, or beginning and end, whatever. I can reset that over to here, 0, 1, 2, 3. Okay. Okay. Now I'm going to do it again. Now doing it again, I could do it recursively, but as we've learned, recursive are not very efficient, and this is not too bad just to keep calling it again within a while loop. We'll see the code in a minute. Okay. So now we're going to calculate this again. So now to calculate our middle, okay, we have to have our equals 0 plus 3 divided by 2. And that, yes, I know. I thought I'd put that, but didn't. Okay, 0 plus 3 divided by 2. going to take the integer of that, so that's a 1, okay, which means our new mid is going to be here, okay. So now we're going to look at a sub 1 or 4 and compare it to our search term of 7, okay. So in this case, it's less than, okay. So since it's less than, we're now going to move this position to here over to 1 more than the mid or 2, okay. And we're going to continue on until either the left and right cross each other or until we find what we're looking for, okay. So that's the basic idea. So instead of having to go through every item, we're able to, at each step, and I didn't show it, but then what we had done here, we're able to get rid of that, okay? At each step, you're able to remove half of the remaining items that you have, okay? So it's a lot more efficient. Let's see what this looks like in code. Okay. So we have the binary search here. Again, a similar setup as we had before, and that it's a templated class, okay? And we have our binary search function, which has our constant for the array we're sending in, an integer for the length, and a constant for the item we're searching for, okay? So we're using first equal to 0, last is equal to length minus 1. Then we're having mid here, but we're going to calculate mid as part of our loop down here, okay? So we're setting, as before, our found equal to false. And this time, our while loop is going to be while first is less than or equal to last. Okay, so once first crosses over and becomes bigger than last, we know we're done. The equal has to be there because you're going to get down, in some cases, if you don't get lucky, you're going to get down to 1 item. Okay, so first and last could be the same. Okay, so if that is true and it's not found, because once it's found, we're going to stop. Okay, we're setting at the beginning of the while loop our mid to be equal to first plus last divided by 2. Again, these are integers, so it's going to just lop off whatever fractional portion that there is, okay? So we don't have to worry about making that decision, okay? We then are looking at the 3 cases we have, okay? So this is the first case that item is equal, okay, to what we found. The second case, we have that the item, well, let's look the other way around. So yeah, that's fine. Okay, in this case, we're going to say that the item, if you read this other way, is smaller. And then the else becomes that the item is bigger. Okay, item's bigger, okay? So let's say if list submit, if it's equal to the item, okay? So this is where we're at in the list. If it's equal to what we're looking for, boom, we're done. Found is equal to true, okay? If not, we're seeing if the item we found is bigger than the item, okay? If it's bigger than the item, it means that the item is smaller, not small, that's not a word, but you get the idea, okay? Which means we can move that last marker over to the mid minus 1. And then anything from mid on, we don't care about. Else, if it's not greater, not equal to, not greater than, it must be less than. Okay, so what we found is less than the item, so the item's bigger. We're then going to move the first. So we're moving the left marker over to the mid plus 1, and we're ignoring the mid plus everything to the left of mid. Okay. And then as before, if found is equal to true, we're going to return that mid position because that's where we're looking for things, okay? And if found is not true, then we return -1, okay? So down here, we have the same kind of a deal, only this time we have to have a sorted list, okay? If you don't have a sorted list, it's not going to work. So I made up some numbers here that are sorted, okay? And I'll set my integer length here again to 8, okay? As before, I'm going to go ahead and print these out just so we see where we're at. Okay. As before, I'm going to ask for a number, do a binary search. We're going to go from there. Okay. So the test program is more or less the same, except for calling this has to be sorted. Okay. And it's sorting the next thing we're headed to. Sorting is a big problem in computer science, or a big challenge. Sorted just gives you a lot of better things for sure. Okay. A lot of better performance. Okay. So let's take a look. I do this binary search. Although I have to do it on exe. What am I doing? Didn't I just do this? Oh, apparently I didn't. Okay. I thought I had done it the right way. I didn't. Binary search.exe, binary search.cpp. There we go. Now we can do that. Okay. So now we have them, are searching. Okay. Again, we'll check for something in the middle, 56. Found it at location 4. And we can check that 0, 1, 2, 3, 4 is correct. I want to test it again on the first item. Okay, found a location 0. I want to test it on the last item, 199. Found it at the last position, which is good. Try it one more time with something it doesn't find, like 888. Not found. Okay, so that seems to be working. Okay. So when you look at the efficiency of this, it gets a little more complicated to figure out mathematically, but the concept's pretty straightforward. So every time that you do a search, you're able to reduce half of the possibilities. Okay. So if you have 100 when you first start searching, 100 possibilities to search through. Okay. After you search the mid, you reduce it to 50, and then to 25, and then to 13, and then so forth. Okay. If you don't find it. Okay. So it's a more efficient algorithm. Okay. And then the book talks about the performance here. And it turns out that we can model this half reduction every time by a logarithmic function. Okay. And again, you can read more about it, but I'm not going to ask you a lot of real detailed questions on this. Okay. And it gets to this concept that you will spend the entire class in algorithms talking about of big O notation. Okay. So I would read through that as kind of a preview, but there are different efficiency classes. And it turns out that sequential search is something we would call a linear algorithm, and that it takes, for n items, we have n things to do in the worst case. Okay. And for the binary search, it turns out to be a logarithmic. Okay. So that it's going to reduce by half every time. Okay. So that's the idea behind searching. And that's really, I mean, there are more complicated searches you can do if you're doing like text pattern matching and all that. But as far as just searching for an item, this is pretty much the options you have. Okay, so if you have a data structure that is not sorted, your options are either to sort it and then do a binary search, or you have to do a sequential search. Okay, sequential searches always work. Okay. So we'll do an in-class example for sure to expound on this, but this is the idea behind searching. Okay, so I just wanted you to be familiar with this. Okay, it's our next topic. Okay, then the next thing we're going to go to is going to be different ways to sort.